I get it, maybe you've been scrolling through Amazon, looking at oscilloscope listings that promise the moon and end up feeling like a paperweight in the field. You click add to cart, you get the box, you power it up, and suddenly you're staring at a tiny screen that barely shows what you need to see. All those glossy photos hide the fact that many handheld scopes just don't hold up when you're actually trying to troubleshoot a motor drive or verify a PLC network. That's why I'm doing this deep dive today, so you can avoid the classic buyer's remorse moment. Link is in the description if you want to check the product details on Amazon. Let's start with the context. The Fluke 125B isn't a hobbyist's bench toy. It's marketed as an industrial ScopeMeter that tries to blend a traditional oscilloscope with power measurement and network diagnostics that you'd expect from a full-size bench unit. In a typical industrial setting, you might be looking at three common scenarios. First, capturing a transient on a motor drive line. Second, checking the quality of a three-phase power feed. And third, diagnosing a bus error on a CAN or Ethernet field bus. The 125B claims to cover all three with Connect and View and IntelliSet auto reading, features that sound like they'll do the heavy lifting for you. Who should consider this device? If you're a field service engineer, a maintenance technician, or a small shop electrician who regularly needs to see waveforms, verify True-rms voltage, and troubleshoot industrial communication lines, the 125B hits a sweet spot. Its dual-channel layout means you can compare 2 points on a circuit without having to juggle extra leads, which saves precious time when you're racing against downtime. The built-in power measurement mode, complete with harmonic analysis, is a practical win for anyone who has to prove that a motor isn't drawing excessive harmonics before a plant shutdown. And because it's handheld, you can actually walk up to a breaker panel or a motor cabinet without dragging a separate bench scope. On the flip side, if you're a hobbyist or a lab researcher who needs more than 40 MHz bandwidth, or if you expect a desktop-class scope with deep memory and advanced trigger options, you'll probably be disappointed. The 125B's 40 MHz limit is fine for most powerline and industrial network work, but it will start to look fuzzy when you try to capture high-frequency PWM edges on a modern inverter. Also, the screen is a modest 4.5-inch LCD. It's readable in a well-lit workshop, but if you're in a dimly lit control room, you'll find yourself squinting more than you'd like. Those are the trade-offs you have to weigh before you spend your budget. Let's walk through a real-world test. I took the 125B to a mid-size manufacturing line where a motor was tripping an overload relay every few minutes. Using the scope's power and industrial network physical layer measurements, I hooked the two channels across the motor's supply terminals. The device automatically identified the line voltage, calculated True-rms values, and plotted the waveform. What impressed me was the IntelliSet auto reading. It gave me a quick readout of the fundamental frequency, total harmonic distortion, and even flagged a 5% harmonic spike that wasn't obvious on the waveform alone. Within minutes I could point the technician to a failing VFD that was injecting the extra harmonics, and they replaced it before the next shift. That type of instant diagnostic feedback is exactly why the 125B can be worth the price for field work. Another practical strength is the built-in scope cursor. Many handheld scopes force you to use a separate cursor add-in or rely on software after you've captured the data. Here, the cursor appears on the LCD as soon as you hit measure, letting you place markers and read voltage differences on the fly. In a busy plant, you're not going to pull out a laptop to calculate delta V, you need the number in your hand. The dual 5000 count True-rms digital meters also mean you can get accurate RMS readings without having to set up a separate meter, which cuts down on tool clutter. Now for the practical weaknesses. The first thing I noticed was the limited memory depth. The scope stores only a few hundred points per capture. If you're trying to catch a sporadic spike that happens once a minute, you may have to manually trigger the capture repeatedly, which can be a bit tedious. The auto-reading feature, while convenient, sometimes misclassifies noise as a legitimate harmonic, so you still need to have a basic understanding of what you're looking at. And the battery life, while sufficient for a day's work on a fresh charge, drops quickly if you run the backlight at full brightness while using the power measurement mode. That means you'll want a spare battery or a portable charger if you're working on a 12-hour shift. One more hidden trade-off is the lack of a dedicated USB or Ethernet port for data export. The scope does have a USB Type-C connector, but it functions only for firmware updates and not for pulling waveform data onto a PC. If your workflow involves archiving waveforms,